All right, so welcome everyone to this is our second GenDD Lab Live. The last one had a lot of great discussion, audience interaction. Looking forward from the same for this one as well. And if you're curious, like we say GenDD, just for context, that's generative-driven development. That's our methodology for applying Gen AI all across the entire, software development life cycle to accelerate speed to value. So if you hear us saying GenDD, you're like, what the hell is that? That's what it is. But today we got a really awesome topic for you. So David Berrio joining us again. He's one of our senior AI ML engineers back again. And we're hitting on the topic today of small language models. So we hear a lot about LLMs, large language models. We're talking small today. And we're going to hit on, what it is, how to apply it, its benefits. And at the end, we're actually going to walk through like a real POC applying this to a couple of domain specific use cases. That's typically how we do it in these GenDD labs. It's not just, PowerPoint talking head. We actually get in there and do some cool stuff. But yeah, please stick around for the demos towards the end. They're really cool. And ask any and all questions in the chat. We will answer those kind of through the conversation as all. It's, a real kind of a fluid type of discussion. So yeah, it's a pretty fun time. So I will turn it over to David if you want to kick us off with the discussion.
Okay, sure, Matt. Thank you so much for the introduction. And yeah, let's go start with this topic. So let me share my screen here. Sorry. Let me know
There
if
we go.
you're able to see the presentation.
Yeah. Yep,
Okay.
that's good. We got it in share mode.
Okay, awesome. Okay, yeah, so as Matt was mentioning, today we are going to talk about a very interesting topic. This is a topic that I think is going to be very relevant for the remaining months of this year and the coming years, because I think there are lots of opportunities on a small language models. So basically the title for this GenDD webinar is how to use small language models for domain specific use cases. And yeah, so today's goal is to present a couple of use cases and talk about an end-to-end POC leveraging open source, the small language models for domain-specific use cases, and try to understand also what is all of this about? What's the concept behind a small language model? How it is different to large language models? And we always if you are around in LinkedIn, for example, you will find lots of people talking about many different topics nowadays related to AI, and sometimes it can get confusing because there's lots of information out there. So what we want to do today is like trying to get or deliver some clarity on this concept, and maybe give you the ability to think about ways that you can use this in your own companies, in your own situations, your own projects. So that's the idea of this GenDD lab.
Yeah, I
Um,
don't know if we got anybody from Texas, but it's always bigger is better. And that's not always
yeah,
the case, right? So I think we'll get
yeah,
into some of that where small is actually better.
yeah, exactly. Yeah, so this is exactly that case. Um, And yeah, so I think this is going to be very relevant before getting into the details because as we have discussed on previous webinars, I think this year or the remaining months of this year, many companies are starting to move from POCs to real implementations, and they are facing lots of challenges when they're trying to move POCs they built with LLMs. And with models that require a huge infrastructure to deploy or that are very costly for using on-demand services. So many companies are facing the issue of pricing and the issue of scalability of their solutions, because basically large language models, as we know, are very hardware demanding. Um, and yeah, they are also they have lots of latency as well, because they do lots of processing because they have billions or even trillions of parameters. So sometimes it's hard to scale those LLMs to real life solutions. So I think small language models are going to play a very important role on this transition between from POCs to real life and production ready systems. So before getting like deeper into the concept, I would like us to think about two use cases. So this is the first case that I want to bring. So let's say you're a company that are looking to enhance its financial oversight. You want to have a better tracking of your expenses, and it's always kind of a daunting task trying to process hundreds of receipts that come to you daily. You might even have people working on that task, and you know, people that might use their time for something different. They are spending lots of time trying to extract information from receipts or documents. Um, and it's challenging because each receipt might have a completely unique layout, a different structure. So that's usually a challenge for extraction from an extraction perspective, because let's say you want to extract, for example, vendor names, dates, amounts, different item descriptions, probably the amount of taxes that you paid on that particular invoice. Um, and that's usually a challenge. It usually requires lots of manual efforts. Or as we know, we can use probably large language models for this. You can upload one of these invoices to ChatGPT, which is using GPT-4 in the background, and it will be able to answer many questions about this. But yeah, that's a possible solution. But I wanted to think about how we can scale this, because this is something that many companies are definitely facing. They are facing the the necessity to process thousands of these kind of documents, and it's kind of a daunting task. And
And I
let's
think
talk.
like just on
Yep.
that use case right there,
Yes.
and this is like something where we try to, get people to change their way of thinking. Like
Yeah.
this stuff goes way past the chatbot, and this is kind of a cool example where
Exactly.
this could be part of a either custom solution you have, something internal with your process, but really like this is a invoice or receipt or whatever. But think of any
Yeah.
type of document that's kind of maybe a bit unstructured in nature. That's where this stuff does some really cool things, right?
Yeah, that's a good point, Matt. I think it's one of the goals also of this webinar is to help people think outside of the chatbot application, and
Mhm.
definitely AI and LLMs and SLMs and you know, any AI approach has much more applications than just chatbots. So this is also an opportunity to try to think broader and see other opportunities outside of that scope. Um, so yeah, we also think about I'm thinking about a second use case. So let's say you are a career company that aim to ensure the integrity of packages throughout your whole distribution process. And you know, packages are always you know, at risk of receiving damage. They go from different stages, let's say from the initial receipt to different storing facilities, and finally to delivery to the final client. And for career companies, it's crucial that they can maintain the condition or the good condition of the packages that they are delivering. So to achieve this, a company could hire operators that can capture photographs of each package and at every steps of the distribution chain. And they can have people that is manually validating, or they are even showing those pictures to the final user. So once they go to their web page and track their package, they can see how it's I mean, what's the current state of that package? But let's say they want to use, in this case, an AI model that is designed to compare those images that they are capturing and try to compare and detect possible damages generated during different steps in the distribution process. And this might have lots of value for them, because that can help them get visibility on, okay, on which steps we are getting more damages on our packages, which are like the more crucial steps that we need to pay attention to deliver a better service to our clients. So this is the second case. If you see they are completely different, I wanted to bring like cases that are from completely different industries with completely different kind of data. The input for for the first case is like you know, invoice images. The input for this second case is probably pictures of a box, or yeah, something as simple
Yeah.
as that. Um, so yeah, again, this is just for you to have like a broader perspective and try to think about potential applications that you might find in your particular scenario. Um,
Yeah, I
so
think too, real quick there, like you
okay,
hear another concept just for this second use case. You hear people
yes,
talk about modalities, multimodal. That
yeah,
second one's using something called like computer vision. So that's getting into a
exactly,
different modality So again, trying to think, it's not just chat, not just text, other things
Yeah.
as well. And I think the 517 GenDD lab, we actually go deep into like the computer vision multimodal.
Yes.
So
Yeah, yes, exactly. That's also a key point. We have multimodality right now, and it's awesome the opportunities that are enabled to us. So yeah, we'll have a webinar completely related to that topic, and yeah, we are going to talk a bit about this also today. Um, because yeah, definitely, even in the first use case, we're also using images as the input for our model. So it's
yeah, that's true.
interesting, yeah,
Yeah.
how on both, I mean, the approach might be different because for the first one, internally, what we are going to do is like try to extract the text from the image and then try to classify that text. On this second use case, we are going to analyze the image purely as it is. But yeah, this is definitely a good example of how we can use multimodality to solve real life problems.
And if it can handle the amount of Amazon packages my wife's ordering on a regular basis, then it's something special, I think. We got
Yeah.
stuff showing up every day in our house, I feel like, from Amazon.
Yeah. Yeah. So okay, so thinking about these two use cases, we can say like, okay, LLMs are a possible solution in both cases, and I think all of us have experimented with ChatGPT. If you have not, you should. Um, and we know that, for example, if we upload an invoice image to ChatGPT and ask a question about that invoice, for example, yeah, any of the questions that we asked before, like what was the total amount of the purchase, what was the tax paid there, who is the provider, who was the buyer, what is the invoice number. Probably ChatGPT, which is using GPT-4 in the background, is going to be able to answer any of those questions. The same for the box. I even have an example of that I will show in a moment. We can upload an image of a box to ChatGPT and ask a question related to its physical condition, anything related to it, and it most likely will be able to answer correctly. Um, so that's awesome. Yeah, and where I want to get is that yeah, LLMs are a possible solution in both cases, and we have lots of LLMs out there. So we have GPT-4 that we are talking about. We have other options like Mistral Lerche, the newest released Cloud 3 models. We have Gemini, we have Grok from Elon Musk, and yeah, we have lots of options out there that we can use and can definitely be a good solution for any of these use cases. But now I want to ask this question. I mean, there are good solutions, but are they the optimal solution? So let's think about it. So why why do we think our LLMs are so powerful? What makes them such a strong solution for many of these use cases and for such a diverse such a diverse universe of problems that we can solve with LLMs? I would say there are like two main reasons. We have the knowledge of the model and the reasoning capabilities of the model. So LLMs are trained on a huge, and when I say huge, I really mean it. They're trained on a huge set of data. As we were discussing previous, we started the webinar. For example, GPT-4 was trained on the transcript of most of YouTube videos because yeah, basically they were running out of data in the internet. You can think about that. That's huge. That's lots of information that they are using to train it. So that's knowledge that those models have internally. But they also have reasoning capabilities. They are not just like a huge library that will drop information to you. No, actually they can use that information to make inferences, to try to understand concepts, to do some sort of reasoning inside to be able to answer to whatever the user is asking based on its knowledge, but also empowered by that reasoning capabilities. So
And just as like it's like you mentioned how much like ChatGPT for example is trained on. I think it's like, I mean, it's billions of
yeah,
parameters, right? I think 220 billion or more probably. Uh, which it's like having a Ferrari for
Exactly.
Maybe all you need is a Honda, right? It may look cool, but
Yeah,
it comes at a
exactly.
cost.
So yeah, that's where I want to get. And yeah, for example, GPT-4, that's not like an official. It's not official information because it's a closed model, but people say out there that it should be around 1.8 trillion parameters. So that's definitely
So I
insane.
was way off on the low end.
Yeah,
It's in
yeah,
the
yeah.
trillions.
Yeah, GPT-4 it's supposed to be on the trillions, so it's definitely huge. Um, so yeah, before getting to that point, I want to think again about those use cases that we discussed before. So let's go back to the case number one, the one related to the invoices. So we'll need. So how will we solve that problem? Probably if we are going to use an LLM like GPT-4 or any of the ones that we mentioned before, we will probably need a fixed set of prompts that are not even open to external users, but are predefined in the backend of an application. So some examples can be, okay, what is the purchase amount on this invoice? Who is the seller? Who is the buyer? How much tax was paid? Like a fixed set of questions that we can append in a list probably, uh, and are not open to a user. I mean, this is intended not to be deployed in an application where a user is going to ask anything about the form or about the invoice, but instead it's going to always be processing the same questions about thousands of invoices that it's going to be receiving. And so let's say a really brief architecture will look like this. We are going to get a receipt image that's going to go into our backend. That backend will have a set of prompts, as we discussed, just like a set of questions that we want to ask about that invoice or that receipt or that document. Um, and then we are going to send that receipt to a language model along with that set of prompts, and we're going to get an answer for each of those prompts. So that's most likely how it's going to work. So if you see, the key here is that we are limiting the usage of the language model for a very fixed set of questions or set of prompts. Let's go to the case number two. And again, how can we solve this with an LLM? I mean, probably if the only thing we want or the only thing we care about is like having like being able to track the physical condition of the boxes across the different distribution steps, probably again, we are going to have a fixed set of prompts that are not going to be asked by the user, but most likely are going to be predefined in your backend, and you are going to have questions um, yeah, what is the physical condition of the box? What is the ID of the box? I know is the content visible, or any kind of questions that you can come up that will add value to your process. And you might even want to compare a picture of the box in one state with with a photo of the box in the other in a previous step, and say, okay, yeah, it looks like the physical condition is preserved, or no, I can see a decrease in the quality of the physical condition of the box from this picture to the other. So are probably the most likely solution for this is that you are going to have fixed questions in your backend that you're going to be asking to them all over and over again. So yeah, probably the solution in this case is going to look like this. Also, this is a very raw architecture, but something like this will have an input of one image or two images coming from one or two pictures from the box or whatever number you want. That's going to be fed into your backend. You are going to have a set of prompts that are based basically on your necessities, on whatever you are wanting to track. And then those two inputs, I mean, the images and the prompts are going to be sent to the language model, and the language model is going to be able to answer and provide the information that you want to have, and be able to store that into a database to then display that to a final user or whatever. It really depends on the case, but it's going to look something like this.
And that's where you can
So
start to like automate some of the solution to like
yeah,
so much of us are used to like actually
exactly.
writing the prompts in ChatGPT, but this is architecting a solution with those being predefined and
Exactly.
fine tuned is probably not the right word, but you're refining those prompts, and the system is just working in effect to,
Yeah.
achieve some outcome that you've defined.
Yeah, exactly. This will work more similar to how traditional AI and and ML models worked. Uh, that they have like a very specific task and they do it over and over again. LLMs are great because they have the ability to adapt to multiple scenarios, but yeah, sometimes what you want, and let's go back to this slide here, is that you want to keep some of its reasoning capabilities, but you don't need all its knowledge. You don't need everything that it's able to answer. You don't want an LLM that is going to be answering questions about an invoice to know, when was Rome Empire founded or something like that, or or the biography of Elon Musk or whatever. I mean, that's not going to make a lot of sense, and that's what many I mean, that's what many solutions that are on a POC stage right now are doing. They are using models that are extremely big, extremely pricey for solving a task that it's kind of repetitive. That might, I mean, these images can be different and they can come from different contexts. I mean, this still has some level of complexity, but it's very encapsulated into a specific domain.
So on that topic, we got a question in the chat.
Yep.
Is the image converted into a vector? Is a vector database needed? So any
Yeah,
perspective?
Yeah, correct. Most likely you are going to be transforming that image using a multimodal embedding model, and you are going to transform that into a vector. That's most likely the approach that you are going to use. And then even if you don't do it directly, most of the LLMs that can deal with images are going to have that step in their first layer. They are going to have an embedding layer when they are going to transform that image into a vector, so they are able to understand it. So yeah.
Yeah. And if
That,
anybody's curious about like what is a vector and all that, put it in the chat and we can hit it towards the end if anybody's curious to go deeper on that or the embedding side.
yep. Yeah, exactly. So coming back to what we were talking about before. So why will we need a model with more than 300 billion parameters, or as we mentioned, GPT-4 has of 1.8 trillion parameters? Why do we want a model with such a huge size and complexity to answer the same question over and over again? Even if the input is changing, even if there's still some degree of complexity in the tasks that we discussed before, because the invoices can come from multiple providers. They can look completely different. They can even come in different formats. There's still some level of complexity, but not as big as the complexity that LLMs are usually, I mean, are designed to solve. They are designed to be able to answer questions about many domains that you don't really care here for this kind of applications. Yeah, you don't need your LLM to know about history or biology when it's going to be checking at boxes pictures the whole day. So um, yeah, it's definitely an overkill, and as Matt mentioned before, it's like using a Ferrari when you definitely don't need it. It's like using a Ferrari to go to
The
one
grocery store.
store away. Yeah, exactly, to the grocery store. So yeah, it's
Yeah.
it's definitely an overkill. You are going to kill your bank account probably with with the gas, with the
Yeah.
taxes for that car, and yeah, it's definitely not what you need.
You look cool doing it, this. There's one benefit there, I guess.
Yeah, exactly. Yeah, that will be like the cool part of this analogy. But yeah, on the LLM world, it won't even. I mean,
Nobody cares. Yeah, you
yeah,
can't
no,
see it.
nobody
Yeah.
cares about
Yeah.
that. Yeah, nobody can see that.
True.
So it's so yeah, exactly. There's definitely no reason for using a model that's definitely an overkill for a very simple or a more limited use case. So now let's go to what are small language models. So small language models are streamlined, smaller, and simpler alternatives to LLMs. And this simpler is something that I will be carefully about, because uh, what was considered a big model 2 years ago can now be considered a small model. So 2 years ago, a model with 7 billion parameters, wow, that sounded crazy. That's definitely huge. But nowadays, that's definitely probably and a small model, or sometimes it's still called a large model, but it's like on the tiny side of large models. So yeah, this is also this is kind of subjective. What is simpler, because simpler today was very complex a couple of years ago.
But it is that kind of parameter count is what's the delineation between. I even just like asked ChatGPT like what's the breakdown there, and it's not like a hard and fast rule. But to your
Yeah,
point, small now is like millions of parameters, which back in the day that was very large. Medium, they're talking like few 100 million, 300 to 500 million. Large, you're getting in the billions, like
yeah, exactly.
Mistral ChatGPT, and then you have like very large, which I guess that's like in the trillions, which ChatGPT's starting to do. So
Exactly. Yeah. So that's something that's always changing. And yeah, the only measure of complexity for a model is not the number of parameters that they have. There are lots of factors involved, like the
mm,
architecture, and other things, but it's usually like I mean, it's a good starting point to measure how big or how complex a model is, and definitely the number of parameters is going to determine how big the file is, and how much memory will you need to process that
yeah.
file or that model. So it's usually related to the cost that will imply like making inferences using that model, or like using that model in production. So it's very related. So that's why we use like the parameters here to talk about complexity. But I just want you to know that it's not the only factor that we need to keep in mind here. Um, so yeah, coming back to the definition, small language models have fewer parameters than large language models. They need less data and take minutes to a few hours to train, compared to LLMs, which require much longer, sometimes weeks, sometimes months. It depends on the hardware that you're using, but it's definitely super expensive. Training LLMs is very restricted to just huge companies with lots of GPU clusters. But probably a small language models is not that much restrictive. Um, so that's something that I wanted to keep in mind. Their smaller size makes them more efficient and easier to deploy on smaller devices or on site. For large language models, most of the time we have to make inferences in the cloud, or use providers like, yeah, like ChatGPT, or on any of the cloud providers that have super powerful and GPU powered instances available for us to use. But let's say we want to deploy a model that works on a, I don't know, on your mobile, or even in the near future. I can think about models running on edge, on, for example, I don't know, IoT systems, and yeah, and the model is running directly inside that device, and not going outside to an external server with GPUs to be able to generate a response. And yeah, and also the small language models shine for their ability to be customized for specific uses, and that makes them ideal for businesses that need a language model tailored for a particular domain, like the ones that we described before. Um, so this is more efficient, this is cost effective, and this has the potential to, yeah, to enable use cases that were not even feasible with LLMs as we know, as they are working right now. Yeah, because sometimes you want them to run on a very small device, to be faster to respond. You want them to, you want them to be good at something specific and be small enough so you don't have to pay huge bills for the service that you are paying to a cloud provider, or yeah, basically this is the idea and the concept behind the small language models. They have fewer parameters, they need less data, they are faster to make inferences, and the most important thing is that they can keep up in accuracy and extraction performance, and reasoning capabilities for the for the specific domain that you train them to be. So that's the good part. You are not going to lose like, yeah, like the capabilities of what you are currently getting on your POC using GPT-4 or ChatGPT. No, they can even increase that capabilities because being smaller, because they are completely focused on solving a particular problem. They can provide a better solution with much less amount of parameters. So this is where these small language models come into play. And this is why I think they are going to be very important in the near future for many companies to be able to actually go into production. So this sounds so cool, but how do we achieve that? I mean, how can we create a small language model, or how can we use a small language model that is already out there? So there are multiple options out there, and your solution might be a combination of these. So the first thing that I want to say is that there are already many models out there that many small language models out there that are available in repositories like Hugging Face, for example, that are already trained for specific use cases. Um, but if you have something much more specific within your company requirements, and you have to build this by yourself, you have multiple options. So you have the option to train a model from scratch. You have the option, and this is the one that we were discussing in the chat earlier today, that someone mentioned is working on this, is doing a knowledge distillation of a bigger model. And the other one will be like fine tuning. So I want to get deeper into knowledge distillation because this is probably one of the more important approaches that are
And
currently
we'll
being
try to
used.
keep this what's sort of high level enough to where
Yeah,
David's good at
exactly.
this, to where it makes sense.
Yeah,
But
exactly.
don't be
Yeah,
scared by the graph.
yeah. We are not getting too technical here. Just want you to understand the concept. So yeah, knowledge distillation is basically, long story short, is just like taking a huge model, a large language model. Let's take as an example an open source model like, I don't know, Grok, for example, the Elon Musk model, and you take that model, which is in the order of 300 billion parameters, and you want to distill that model and transfer as much knowledge as you can from that model to what we call a student model, which is going to be a smaller one, let's say a 7 billion parameter model, or a 1 billion even. We can go as small as we want, and we want to try to keep as much of the accuracy for a particular task of the teacher model. We want to transfer that accuracy to the student model. So this is something that we can do with this process. As we mentioned, there are multiple techniques to do this, and we don't want like to get into the very technical detail on here. But this is a very common approach, what we call knowledge distillation. We basically have a teacher model, a student model, and we transfer that knowledge from one to the other. And the second approach, which is fine tuning, and we can use both. These are not like exclusive approaches. Fine tuning is like taking an already trained model. It can be a large model and a small model. Here, if we want to build a small model, probably what we want is to take I don't know, a small model, let's say a 7 billion model, like for example Mistral 7 billion, which is a relatively good performer model for that size range. And we want to fine tune it to perform better on a specific task. So let's say we want to 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 fine tune Mistral 7 billion to be an expert in I don't know, whatever, for example, creating SQL queries or something very specific, or creating Python code or whatever. Uh, so the good thing about fine tuning and is that fine tuning a 7 billion model with our regular approach will be also very hardware demanding, but we have this LoRa approach, which is very interesting because basically what we are doing here is that we are not going to fine tune the whole model. We are not going to change the parameters for the whole model, but instead we are going to change just a few of them, adding some additional matrices that we are going to modify uh, to make it better at that particular task. So this approach is very popular, the LoRa approach, because it does not require us to have like lots of infrastructure. It does not require us to spend a lot of time and to modify the whole model, just some parts of it. And and if we combine these two techniques, this is like usually the way small language models are created. So we make a distillation from a big model. Let's say we take a 300 billion parameters model, and we distill it to a, I don't know, 2 billion parameter model. Uh, and yeah, probably that 2 billion parameter model is not going to be better than the teacher model at anything. It's going to probably try to do some of the things that the bigger model is doing, but it's not going to be as accurate because it's still trying to yeah, to do all the things that the other model can do. So that's the point where we can fine tune that smaller model to be better at doing some specific task, like for example, examples that we mentioned before, like creating Python code or creating SQL queries, or for example, going back to our use cases, receiving the OCR or the text in contained in an invoice or a receipt, and trying to locate the different entities inside that invoice or that receipt. So yeah, usually the best way to create small language models is a combination of these two techniques. First, make a
Yeah.
knowledge distillation. Yep.
Well, I was going to say, just to read it back, make sure I'm understanding. So that first approach, that's basically like the act of making it smaller. The
Yes.
fine-tuning approach is the act of making it more accurate
Specific.
and tailored
Yeah.
to the use case that you have. So that's kind of how you
Exactly.
tackle it from both sides, right?
Exactly. Yeah.
Yeah.
Correct. Yeah. Yeah. That's the whole idea. Yeah, this one will make the model smaller, and this one will make it specific for something that you wanted to know about.
Which means you
Um,
get to save money and you get less hallucinations, more accurate. So it's always a good thing.
exactly, exactly,
Win,
yeah,
win-win.
yeah, exactly. And again, we want to do this when we have a specific use cases. Of course, it's not like there's a, like we have to pick between, okay, what's going to rule the future, large language models or small language models. No, I think
Yeah.
both of them are going to have like their place. Large language models are great because they are assistants, they can do anything. I mean, I think all of us use ChatGPT on a daily basis because it can help us on every task that we can think about. But these smaller and more specific models are going to have a place probably in industries where they are always like, requiring a repetitive task to be performed. And yeah, basically what we discussed before, these models are, they work more similar to how traditional ML and AI models worked, but with the reasoning capabilities of LLM. So it's awesome. I think they are definitely very relevant, and they will be very relevant in the near future for many companies transition to this AI revolution. Um, okay, so let's take a look at some real life examples. So I created a demo here, basically trying to tackle the first use case that we discussed, the one related to invoices. Um, I just want to show how this can shift like the paradigm of using AI just as a chatbot, start using it more like a, like a step inside your process or application that doesn't necessarily need a human user interacting with it like at every time. Um, so this is where we are going to get. Let me get this here. So this is basically an invoice data extraction demo, and this is using a small language model. It's a 7 billion parameter model that it's fine-tuned specifically on extracting information from invoices and receipts, and what kind of information it's going to extract. Let's do the demo first, and then we can go deeper on how this works. So let's upload this invoice. This is just a sample invoice, and if you see, in a matter of no time, it was able to extract some of the fields that I defined it to do. So what was the total amount of the purchase? We got the value. I don't know if I can zoom this a bit. What is the invoice number? What is the client name? What is the store name? What is the due date, for example? This is just an example of what we can do with this model. Let's upload another one. For example, this, if you see, it looks completely different. Second, I'll upload this again. Uh, let's upload this one. I don't know what's wrong with that other file. Okay, so here it's extracting the information for this one. Let's give it a few seconds.
And for reference, I think some of y'all may see Streamlit up there. Maybe give context to what Streamlit is. It's kind of a cool tool that we've used to kind of build some of these on the interface side
Yeah,
with some of these.
yeah, exactly. Streamlit is a very friendly application to build front end to or to give like an user interface to your AI and or ML projects. Is very straightforward to use and can get you to prototype very fast and develop things like this. Yeah, where you can upload files, process an LLM in the background. So yeah, as you see, basically this what we're doing with this model is that let's extract another one. Is that we are internally what we're doing is that we have a set of prompts predefined as we discussed before. This is not going to be open for a user to ask any question that they want. This is going to have a predefined set of prompts that it's going to ask over and over again to each receipt that it's received or to each invoice. And that's why we don't need a model that can answer anything. We just need a model that is very good at answering this kind of questions related to an invoice image. So if you see, basically what we're doing here is that we are asking each of these questions individually. So we are sending 5 questions to the model, and it's answering very fast. And this is because sorry, I made a mistake. This is not a 7 billion mole. This is even in the, I think this is a 128 million parameter mole. So it's much smaller.
Which is
And
very
it,
small compared to some
yeah,
of
yeah,
the
yeah.
ones
Yeah, yeah,
that we're
definitely.
talking about, right? Yeah.
That's absolutely small. So it's extremely fast to do inference and it's super cheap. For this example here, I'm using basically the Hugging Face API for the serverless inference engine that they provide, and yeah, most of these tests are completely costless because inferencing with this model is very cheap, and it's also super fast. So this is what I wanted to see. So if you see, let's try again with one of these documents. What it is doing internally when it says extracting information is that it is sending each of these prompts to the model, which is similar to how we would ask a question to ChatGPT. It will receive the answer for that question, and it's going to store that answer for us, and then it will go to the next prompt and do the same process. And if you see, it's prompting, in this case I have 5 questions and it's prompting 5 times, and it's giving us five responses in, I mean, in less probably than 10 seconds. Um, so that's why these small language models are so great. And then you can probably at some point do this automatically. You can have for example, for this company in the case one, you can have a repository or a data lake with all your invoices that you're receiving from multiple sources. And those invoices are then automatically processed using a system like this. Um, and then all the instructions can be stored in a database on a spreadsheet or whatever, and you can have track of all of the invoices. So this looks like a more traditional AI and ML solution, but it's leveraging a language model under the hood. So this is, yeah, this is like the kind of shift on of paradigm that we want to transfer in this webinar. We wanted to think about possible solutions where you don't want necessarily to have a user asking questions to a chatbot, but instead, how can I put a model like this inside my system, inside my backend, and yeah, make it solve a problem
And,
that I might have within my company. Yep,
and we got several questions coming up. I'm saving some
sure.
for later, but one that's kind of relevant now. Somebody's asking David Cornelson, could you compound the prompt? So what are the following values: total amount, invoice number, client
Yeah.
name, and due date, and like you kind of build on itself. So that kind of gets into how
Yes.
you architect the solution and the workflow, I guess, right?
Yeah, exactly. That's a good question, and that's also another approach. For this particular case, I wanted to do them like in individual prompts because I wanted to have like individual responses that I could probably, I don't know, store like without having to parse a longer response. With this approach, I can get the specific answers and store them, like for example, in a database or on a spreadsheet or whatever system that you want to use to store this information and to persist this data. But yeah, definitely we can also compound all of this into a single prompt and ask them all to provide a list. And yeah, then probably you will need to do some post processing to that output to kind of split the different responses. Uh, and
I think what's
usually,
interesting. Go ahead,
yes.
keep going.
Yeah, no, and usually small language models like this is, as I mentioned, just 128 million parameters, uh, want to keep questions simple. So that's why I decided to have like individual prompts as well. So I
Mhm.
can have a question and have a short answer and don't add lots of probably confusion to them all because, it's a much smaller model. So probably its reasoning of the question is a bit more limited. So you want to keep it as simple as possible as well,
Yeah.
at least for this scenario. Yeah.
I think what's interesting too, it's, think about a workflow or a solution. And in the past, it's like you're basically setting up if then kind of statements of what it does. But if you start to inject LLMs in there that are kind of defining what it does next, so you can kind of have traditional ways of a solution working software development, but then also injecting in similar to this, the LLM side. But what if
Exactly.
that's triggering a next step in the workflow?
Exactly.
But
Yeah.
we may not need to say like, okay, if this happens, then we're defining every edge case. Like that's where it could
Correct.
start to get really cool, and we may get into some interesting hallucinations there too. But that's where you can kind of see the future going, right?
Yeah, exactly, Matt. I think that's the whole point. I think this thinking about this as something that you can integrate into your in your current software development practices and your current
Mhm.
architectures. Yeah, is the way to think about this and how this can help you solve or empower your application to solve more complex problems than what you're
Cool.
doing right now. Yeah.
So let's hit we got about 10 minutes. I want to leave some time for Q&A. Do you have
Yeah.
the image one as well you want to hit just real quick, and then we'll start to hit some questions?
Yeah, so for the images, I just wanted to bring sorry, not here. I wanted to bring an example of how we are using a large model to answer this kind of questions. So in this
Mhm.
case, I meant to show how will this work on ChatGPT, which is a large model. So I have an example of two different boxes, and yeah, basically the box here, what it says is that the box in the image appears to be in good condition. It gives like a brief description on about each of the images. In this case, it said that the box is significantly damaged, and it did kind of describe the damage that it can see. So I just want to, yeah, to open the door, like, okay, this is what a large model can do, and as we discussed before, this is leveraging a GPT-4 under the hood. But using the processes that we discussed earlier, we can make, of course, we cannot distill GPT-4 because it's a closed model, but we can take any big multimodal model out there. There's a very popular one, which is Java, for example. This one, their API seems not to be working today, but this is a this is a very popular open source multimodal model that you can get the weights for, and you can based on the API is not working today, but yeah, this can basically give us a similar result to what we are getting with ChatGPT, for example. And the good thing is that it's an open source model that we can probably distill to make it smaller, keeping its multimodal capabilities, and then fine tune with lots of, let's say we want to address the use case number 2 that we discussed, then we can fine tune it using lots of box images to be even better than the original Java model. or Lava model. This is basically based on the Llama model, but with vision capabilities. You can
And
use those to
where
process. Yep.
and where like where would somebody even find this? Is this like this would be an example of something on Hugging Face where you could
Yeah,
go in and find
exactly.
the open source model?
Yeah, so Hugging Face is a huge resource for models. So for anyone interested in into getting deeper into this is definitely the way to go. This is a huge repository where you can find models for different purposes. So you can have, let's say we go to image text to text. They recently released this IDFix 2 8 billion model. This is also a multimodal model that can ask can answer questions about images very well. And if you see, it's not such a huge model, it's just a billion model. And you can get, if you see, these models are completely open, so you can get all their weights. Basically, you can get them into in TensorFlow format or PyTorch format, which are like the two bigger frameworks for dealing with machine learning and AI models. And you can get the weights and download the whole repo to have complete control of these kinds of models. And in Hugging Face, you have access to, yeah, as I mentioned, to a huge repository of models with, with different purposes. You also have traditional ML models here. You can find embedding models. Someone asked before if you needed to transform images to vectors, and that requires what we call an embedding model, which is basically a feature extraction model for images. And you can find that kind of models here as well. So yeah, Hugging Face is a great repository for you to start experimenting. If you see almost every open source model provider is publishing their models here. For example, Mixtral recently released their 8 by 22 billion model, which is a mixture of expert model, which is also a very popular approach. For bigger models, and you can find it here already. Since these are open source, you can find then someone who took this model and made a small modification and also published it here, so it might be useful for you. So it's a
Mhm.
great community, very active. There's people working a lot with these models and publishing many cool
Yeah,
stuff.
the open source models
Yeah,
available is just exploding. I saw a chart the other
exactly.
day. I'll have to
Yep.
find it and share it in the GenDD community for everybody, but
Yeah.
it's just exploding. But I think we got about 5 minutes. Are we good to
Yeah.
move to
Yeah.
questions,
For
David?
sure.
All right, cool. One that came up. Um, yeah, so somebody said maybe you've discussed this, but what is the computing power needed for a small language model to run locally? Sometimes cloud hosting costs might be prohibitive for regular
Yes.
users. I think it depends on the model size is one piece, right?
Exactly.
And
Yeah, this is completely related with what we were discussing before about the model size. The number of parameters usually is very relevant for the amount of computing that you need to run a model locally. Usually, well, I would say models below 1 or 2 billions can be run or can be executed even on your CPU locally. For bigger models, I mean, you can still execute them if you have enough RAM, but if you want to get reasonable response times, you might want to have a GPU, even if it's a small model. For example, you want to run a 7 billion model, it will be safe still to have um, a GPU with at least, I will say, 24 gigabytes of RAM, uh, which some consumer GPUs have that amount. Yeah, in the other webinar that we discussed a bit on how to run these kind of models in local environments. So I think that's a very interesting topic, and yeah, it's really related on the size and how small you can go. Also, there's another approach that can make a small models smaller, and it's what we call quantization. So quantization is like techniques to try to make each parameter smaller. Instead of having less parameters, we want to make each parameter smaller.
that's
So
interesting.
yeah, so that's another approach. And recently, Microsoft released a paper, a very interesting paper, talking about 1.58 bit parameters. So usually our parameters are in the 16-bit range. So each parameter size is 16 bytes. 16 bits, sorry. But then you can, with this, for example, with this approach that Microsoft released, each parameter is only using 1.58 bits
Mm.
of memory, and they are keeping up with the performance of models with the traditional 16-bit size of parameter. So there's
Yeah.
lots of research on that area as well, and that will enable in the future, I think in the in the near future, that would enable lots of possibilities for running even bigger models locally and having more performance or having more accuracy with less hardware demand. But
Yeah,
yeah,
if you're
so
curious how to run them locally, I think our first GenDD lab hits on some of
yeah,
that too.
exactly.
But I'm curious maybe we hit this question. We can go long if people want to stick around, I think. But I just put it back in the chat. This is from
Okay.
David, I believe. He said, I'm more interested in the concept of what I call mini RAG. And for those that don't know what RAG is, it's retrieval augmented generation. And we hit on
Yeah,
some of that as well in the first GenDD lab if
yeah,
people want to go check out the recording. But he mentions providing an AI model a set of principles that generates code, then we can add the code to the context, update the principles, and improve the code. And it sounds similar to what we're working on kind of building and defining with as part of our generative-driven development
yeah.
against just traditional software development. But any thoughts there, David? Anything you've seen or people playing around with this, or just it's an interesting topic.
Yeah, definitely interesting. Well, I have not seen like the use cases of mini rack for coding, but I have seen some very interesting for more traditional question and answer applications where they can go very small with the models, but they get very sophisticated in the retrieval side of it and like the side of the embeddings, so they can retrieve very relevant information based on a user question, and and yeah, and basically answer a question based on that. So that's also very interesting because we can take very small models, and as also the retrieval side of RAG evolves, we get more possibilities to, because basically what that enables us is that we don't need to have all the information or all the knowledge within the model parameters, but we can have
Mm.
those inside, I mean, outside of it in a vector database or whatever. And if we get more accurate on how to extract or retrieve the right piece of information that will be helpful for the model to use as context and provide a good answer, that's definitely another way to go and to be able to work with a smaller model. So yeah, that's
Yeah.
a very interesting path as well.
And so we're right at time, but we'll keep answering a couple of questions if people want to stick around. But if you're not already in the GenDD community, go check it out. I think we got some links to that in the chat. We put all our recordings up there. There's a course on GPT. It's a great, just general chat where people ask questions, kind of collaborate a bit there as well. And we also have a workshop we do if you want to go deeper on use case identification or getting your team up to speed, as well as what we call our solution accelerator. So we prototype something in like 2 to 8 weeks based on the scope. So if you want to actually, if you got an idea, you want to make it real, just hit us up. Go in the GenDD community, go to Hatchworks website, and let us know. And please, if you got any other ideas for future GenDD labs, like topics you'd like us to hit on, drop those in the chat as well, or put them in the community. We got several ideas of ones we're going to be doing in the future, but would love to hear what people are hitting on as well. But I think one other question, if people have others, feel free to drop them in. But somebody was asking to elaborate on, we were talking about what a vector is, and they said elaborate on it. What is a vector database? So maybe just some context in terms of like what actually is a vector. I know there's that visual on GPT for all that may be interesting for some
Yeah,
folks.
yeah, I think that's a good one. So I'm going to bring that one here. Uh, Yeah, because this will help understand and visualize like the concept. So basically, yeah, a vector, uh in a traditional sense is just like I don't know why they don't have like the colors today. Oh yeah, it's still loading. Yeah, in a traditional sense, a vector is just like a set of numbers that can be used to map something into the space. So for example, here we have a two-dimensional space, and each of these points is a vector with a coordinate. Yeah, you can recall probably from college or from school, like yeah, how we can map points into a 2D space, and each of these vectors is just a two coordinate yeah, two coordinate vector, because we are in a two-dimensional space here. And what we are visualizing here is like we can map information, like for example text or images, into a space like this. So for example here what we are seeing is a bunch of conversations for multiple and very diverse topics. So if you see here, we have like some of the topics that we have in this data set. And what they are doing is that they are mapping a conversation or a piece of text related to that topic into a vector in this two-dimensional space. Uh, so yeah, that's basically what a vector is. It's like a mapping of some piece of information or some unstructured data, like a text, like an image, like an audio, or whatever you can think about, into an structured a vector space with any amount of dimensions. In this case, this is a two-dimensional representation that we can visualize. In real life applications, this dimensionality is bigger. We sometimes go to more than 1,000 dimensions, so that's something we can't even visualize, or sometimes it can be hard to think about, but it's still the same. You can think about it as the same. Um, yeah, I mean, as the same concept, in the sense that you can start measuring, for example, distances between conversations, and that's something very interesting, or distances between images, for example. So let's say we have some images here. Each of these dots is a conversation or a text, as we mentioned. So we can, since these are mapped into a vector space, which is in this case a two-dimensional space, we can measure the distance between one conversation and the other, for example, or we can start measuring the distance between one image or another image, or we can even do operations between them. Since these are just numbers, these are texts mapped to numbers, we can even I don't know, we can, for example, we can start to add them, we can subtract each one from the other, and that's supposed, I mean, the claim here is that doing that kind of operation will have some kind of semantic meaning at the end. So that's the power of these representations of data into a vector space. And I think this is, I mean, this is something that exists even before LLMs, but definitely is one of the things that makes LLMs so powerful, that they can transform you can transform any kind of information into a point in a space, and you can start to measure distances. And a vector database is just like a huge database where you are storing all of these points. So yeah, basically what we are
And they're
seeing here
represented
is a
as
vector
like,
database.
and they're basically represented as numbers in effect. You're kind of
Exactly.
turning anything from image to text to whatever to these
Yeah,
this
exactly.
list of
It's
numbers
just,
almost.
yeah,
Yeah.
it's just a list of numbers. For example, here, since
Yeah.
this two-dimensional representation, then each text is mapped into two numbers, two coordinates. If you go to 3 dimensions, then you are mapping anything to 3 numbers, and so on. You can increase as much as you want, and it will get
Yeah.
harder to visualize, but the same rules and logic applies.
Yeah, it's crazy. It's hard for like humans to comprehend that a bit. I think that's probably a good spot to stop there. But thank you everybody for joining. Check out, we got another one on May 3rd, another one on May 17th, getting into like Gen AI with software development, and then also multimodal models, a deeper dive on the computer vision side. So some good stuff coming up. But thanks, David, for helping host the chat here.
Okay, Matt, thank you so much, and thanks everyone
All
for
right.
joining.
Everybody have a good day. Have a good Friday, good weekend. See you at the next one. And let people know about future ones. Excited to build the community as we go.